Hi, and welcome again to day 17 of Just Start Programming, creating console terminal apps using Rust and Ratatouille. Today, let's go through panic hooks, crossterm, termion, termwiz, color, IR, and let's try to see if we can run the examples without any issues. So join me once again live in one take, no shortcuts and no secrets. So let's just start programming. All right, so welcome back. So today, let's try to cover panic hooks, crossterm, termion, termwiz. Maybe we can cover this one as well. Color, IR, or if we have time, we can go through this one as well. So there are a lot of examples. Let's try each and one of them and see if it works. So I think mostly what we have here are code snippets. I hope it works so that we have enough time to cover other topics. All right, so let's start with set up panic hooks. When building terminal user interface with Ratatouille, it's vital to ensure that if your application encounters panic, it gracefully returns to the original terminal state. This prevents the terminal from getting stuck in a modified state, which can be quite disruptive for users. The Rust standard library allows applications to set up a panic hook that runs whenever a panic occurs. Ratatouille applications should use this to disable raw mode and return to the main screen. Given the following application that panics after 1 second delay as a basis, we can implement the hooks for each packet. Okay, so what we have here? We have main, IO result, init panic hook, init UI, UI draw frame, panic. Okay, so I think this one looks like code snippet. There's some missing codes here, init panic hook and init UI. But what does this mean? So we have this one, and here we have this one as well. Maybe we need to refresh our memory. About error handling. Okay, let me open up the Rust programming language. Is the book? It's the book. Error handling. Here, error handling. Panic. So this is the panic macro. We have it here, panic. How about this one? Implementation uses the question mark operator. Question mark placed after result value is defined to work in almost the same way as match expression. We define to handle the result values in listing 9-6. It's 9-6. So you have result, IO error. So it's either username from file, username file result. So either OK or error. OK or error. So text. Place after the result value is defined to work in almost the same way as the match expression defined. Okay. If the value of the result is an OK, the value inside the OK will get returned from this expression. Okay. So if the value is OK, the value inside OK will get returned from this expression. The program will continue. If the value is an error, error will be returned from the whole function as if we had used the return keyword. So the error value gets propagated to the calling code. Okay, let's come back here. Frame area. So if there's an error, what does it do? If there's an error, so it will return, propagate it back. The question mark operator eliminates a lot of boilerplate and makes this function implement simpler. Even shorten this code further by chaining method calls immediately after the question mark as shown. The question mark operator does error values that have the question mark operator called on them go through the from function defined in the from trait standard library, which is used to convert values from one type into another. When question mark operator calls the from function, the error type received is converted into error type defined in the return type of the function. This is useful when the function returns one error type to represent all the ways a function might fail, even if parts might fail for many different reasons. So here, the error will be returned from the whole function as if we had used the return keyword. So from here, if there's an issue, result will return an error. Okay, so I don't think we can run this because we don't have the contents of this one. Okay, Ratatouille applications should use this to disable raw mode and return to the main screen. Return to the main screen. Return to the main screen. I think this example feels I think if we have the code here which you can run, init TUI. Init TUI. So usually in Ratatouille, what do we have? Okay, this one cannot run. Let's close this. Hello, Ratatouille. So main, we have init and restore. Restores the terminal to its original state. Roll mode is disabled. Okay, so if we have init and restore is here, assuming this is the init part, if there's an issue somewhere here, sleep duration from 1 second. Panic. This is a panic. Where's the hook? Init panic hook. Init panic hook. Okay. Oh. Okay, so I think it's over here. Crossterm. Let's continue. Storing the terminal state in an app that uses crossterm backend is pretty simple. The init panic hook method saves a copy of the current hook and sets up a new hook that restores the terminal to the original state before calling the original hook. It's important to avoid panicking while restoring the terminal state. Otherwise, the original panic reason might be lost. This might be supplemented with a login to a file or similar. Okay, so this one looks like a full application. Maybe it's something we can try. Panic hooks. Cargo new. Set up panic hooks. Let's see if it will compile. It's Ratatouille. Okay. Need to include this one. Okay, so let's inspect the code. Main, and we have the panic hook over here. Panic hook, original hook. What is take hook? Take hook unregisters the current panic hook and returns it, registering the default hook in its place. If the default hook is registered, it will be returned, but remain registered. The following will print normal panic. Custom panic hook. What does it mean? The init panic hook method saves a copy of the current hook. Okay, init panic hook method saves a copy of the current hook. Take hook from panic. Okay, original hook. And then sets up a new hook that restores the terminal to the original state before calling the original hook. Sets up a new hook that restores the terminal to the original state before calling the original hook. Sets up a new hook that restores the terminal to the original state. Restore, okay, restore TUI is here. Restore TUI, it calls the disable raw mode. Execute std out leave alternate screen. Original hook. Okay, so it says here intentionally ignore errors here since you're already in panic. So before panicking, it will restore it first. And then panic info, original hook. I think this is the key point here. It sets up a new hook that restores the terminal to the original state before calling the original hook. Restore TUI is here before calling the original hook. It's important to avoid panicking while restoring the terminal state, otherwise the original panic reason might be lost. In your own app, this might be supplemented with logging to a file or similar. Init panic hook. Okay, so panic is forcibly called here, so it will panic. But according to this, since we have this, it will try to restore the TUI first before it completely panic. Okay, so let's try to run this. We need to run the main. To run. Thread main panicked. What will happen? What will happen if we don't have the panic hook? So I think this will render the terminal unusable. Let's see. Yeah, exactly unusable. Somehow something is there, but it's messed up. Because I think it entered the raw mode and then we forcibly called the panic. Right, so I have to close this. A new terminal, maybe we can do it from here. And let me just put this back. All right. So I think this is the key part. Take hook, what does it do? Unregisters the current panic hook and returns it. It returns it. So it returns it as original hook. And then here, set hook registers a custom panic hook replacing the previously registered hook. Set hook box new. Set hooks in box new. Then you have closure. So you have the panic info. And you call something here restore DUI to disable the raw mode. Leave alternate screen. What does it do? Alternate screen. Do anything on the alternate screen. And returns OK. Right. So this is the pattern. It's important to have this in the code as well, so that if the terminal panics, then there's a way for us to restore it. So we can remove this part, since this part will forcibly trigger the panic. The result, maybe we can provide OK. Mismatch. Okay, is it a mismatch? is result. Color IO result. This is IO result. IO result. IO result should be this. Okay. Why is there an error now? Okay, so let's run this. So this will happen mainly because we did not restore TUI. So we based it, this example, after running everything, we need to restore it. So after rendering hello world, we need to restore TUI. Restore TUI. Fine. Cargo run. There. Oh, the only problem is that hello world did not show up. Hello world did not show up mainly because usually we will have a loop inside this part. So just like here, app new run terminal, there's a loop. Yeah, so that loop is missing. So it might have rendered this part, then it tried to restore the TUI. Probably we can try sleep. Let's try sleep, and maybe let's put 10 seconds. 10 seconds, so we should at least see something. I think that's more than 10 seconds. Yeah. All right. So that's how it works. It means we can do something like this. Take the hook, assign it here, do a restoration of the UI, and then put it back. So that at some point while rendering, something happens. At least there's a way that the terminal can be restored. Alright, so let's move on. What do we have here? Termion. Termion requires a bit more effort, as the code for enabling and disabling raw mode is only available on the raw terminal type. The type stores a copy of the terminal state when constructed and then restores that when dropped. It has a suspend raw mode function that temporarily restores the terminal state. To make it possible for the initUI method to see the terminal in a cooked state, opposite of raw, the init panic hook method needs to create a raw terminal, which will be used in the panic hook, and immediately suspend raw mode. Termion provides a similar wrapper type for the alternate screen, but this type doesn't implement a method to leave the alternate screen except when dropped. Apps should use to alternate screen to main screen instead of the into alternate screen wrapper. Also make sure to call stdout flush to make this change take effect. So this is the termion approach. Why do we have crossterm, termion, and termwiz? I think there was a criteria previously which backend to use. Yeah, so maybe let's take a look at this part. Comparison. So here is the TUI only for Western users. If yes, then that's termwiz. We have termwiz here. Okay, so termwiz is this one. So it's a little more difficult. I don't have the example here as well. Okay, so if no, is Windows compatibility important? If yes, you can use crossterm. If no, are you familiar with crossterm? Then you use yes. If no, are you familiar with termion? If you know termion, then yes. So that's why we have the termion approach here as well. Termion backend. So termion will have into raw mode. Is it compared to this one? Crossterm backend. Crossterm, you have disable raw mode, enable raw mode, enter alternate screen, and leave alternate screen. For termion, you have into raw mode, to alternate screen, and to main screen. So the structure looks somewhat similar. You still have the init panic hook here. Init panic hook. Okay, so this is the difference. Into raw mode, suspend raw mode. Suspend raw mode. Function that temporarily restores the terminal state. Terminal state. Temporarily restores the terminal state. Okay, then take hook is here. So there's another suspend raw mode here as well. And then restore TUI. So restore TUI. Okay, so this is how the terminal can be restored. So it's a different approach, but the structure is the same. So there's a panic hook. So this take hook and original hook is important. How you would restore the TUI. So in termion, it has its own way of doing it. Okay, so no need to run this one. Anyway, I think it's almost similar structurally. I mean, init panic hook, take hook. So the panic is also forcibly done here. So it will restore the TUI. Restore TUI here. Okay, and then in termwiz, we don't have anything. So let's skip this. And conclusion. As a general rule, you want to take the original panic hook and execute it after cleaning up the terminal. Execute it after cleaning up the terminal. Is it done? Original hook, maybe this part. In the next sections, we will discuss some third-party packages that can help give better output for handling errors and panics. Okay, so let's move on to color error hooks. Use color with Ratatui. Full source code is available at how to color How to color Let's take a look. Oh, it's not found. It's not found. How come? It's not there anymore. So it means the documentation needs to be updated. How about this one? The color crate provides error report handlers for panics and errors. It displays the reports formatted and in color. To use these handlers, a Ratatouille app needs to restore the terminal before displaying the errors. Color install. You see this part. Let's take a look at the hello Ratatouille. It's it somewhere here. Color result. Color result. Install. Install is here. I think that's the first step. Color install. Init. Run failed. Restore. So what does it do? Your terminal initialization function adds a new code that replaces Rust default panic handler with one that restores a terminal before displaying the panic details. This will be used by both panics and unhandled errors that fall through the end of the program. Okay, so set panic hook, take hook, and set hook. Okay, so this is how it looks. This is the first step. I reinstall the hello Ratatouille. Let's see if there's no panic hook. Restore is here, but there's no set panic hook like this. Usage. In your application, wrap errors with extra context as needed. Add the following import. Error. Run failed. Okay, then here's the demo. Put this here. Maybe we can try this one in a new application. Volume, what should we call this? Color error books. What TUI? Do we need this? What's TUI? Oh, TUI is here. Okay. Okay, so then cargo run, we should be able to see something like this. Press Q to quit, P to panic, E to error. Let's try P. Okay, application panic, trash. Is it similar to this? Application panic, trash. Okay. Then with Rust, backtrace full. E to panic. Is there any difference? It looks the same. It should look like this. How do we run it like this? Okay. 10 frames hidden. Okay, so it looks similar to this one. And how about error? Error E. Okay, 0 run failed, user triggered error. Okay, so it looks like this. And if you do it like this, E. Okay, then you have a lot more information. Normal exit. Exit. Q. Okay. So what's special about this one? look at the code. You have this, color IRE install. Then you have a print line macro. Failed to restore terminal. Somehow this one did not show. And then here, what do we have? Q, P, and E. Okay, so when we press P, panic, it forced it to panic. User triggered panic. So if it panics, then what will happen? There's this set panic hook, set hook, restore. Okay, so it's just that the result that is being used is color IRE result instead of what do we have in the previous example, panic hook. This one is just IO result. I think that's the only difference here. It displays the reports formatted and in color. If you want it in certain format and in color, then you can use color IRE. Okay, so let's move on. Let's move on to okay, so if you want advanced, there are other documentations here, examples specific for color IRE. We can explore that in the future also. But let's stick to the topic and proceed with better panic hooks. Your application may panic for a number of reasons. Example, when you call .unwrap on a none, and when this happens, you want to be a good citizen and provide a useful stack trace so that they can report errors back to you. Not leave the user's terminal state in a botched condition, resetting it back to the way it was. Better panic. Better panic gives you pretty back traces for panic. Okay, so it's another cargo crate. Another crate. Initialize panic handler. Okay, so initialize panic handler. Set hook. So it's almost similar to this approach. You need panic hook, and then you have set hook. Take hook and set hook. In this case, it is set hook. There's unwrap, and you can disable raw mode. Panic info. Okay, and here It says, I personally like to reuse the TOI struct in the panic handler. That way, if I ever decide to move from crossterm to termion in the future, there's one less place in the project I have to worry about refactoring. Here's an example of initialize panic handler using panic and libc to provide a prettier backtrace by default. Okay, so there's initialize panic handler, set hook. Better panic. Better panic. How is it compared to this? Panic info is here. Line number suffix. Okay, so it's being handled here. Okay, an error, unable to exit terminal. Then what is this? Better panic settings auto. Most recent first line number suffix, verbosity. Okay, so it's a better way to provide a prettier backtrace by default. Okay. Now let's say I added a panic to an application as an example. Panic is here. This is what a prettier stack trace would look like with better panic. Backtrace. Does it show? Multi-threaded. With the dot most recent first false, the last line of the stack trace is typically where the error occurred. So it means this one is at the application upper S line 80. Panic at the disco. So that is here. Assuming it's in line 80. So with most recent first false, the last line of the stack trace is where the error has occurred. This makes it fast and easy to find the error without having to scroll up the terminal history and iterate on your application rapidly during development. This kind of detailed stack trace is only available in debug builds. For release builds, you may get inline or truncated stack trace. Okay, so if it's released, then this is what you see. Panic at the disco. 980. This is not particularly useful to show the average user. We'll discuss better solutions for what to show the users of your application in the following subsections. Oh, there's another crate. Human panic. Yeah, you'll have to install it as a dependency. Personally, I think human panic provides the most user-friendly panic handling functionality out of the box when users experience unexpected panic. Okay, so more user-friendly. It generates a report where information relevant to the crash is logged. Here's the content of the temporary report file that Human Panic creates. Okay, so I think this part here is from release. If it's a release build. Anyway, I think this is the most important part. in app.rs at line 80. Panic at the Disco. Is it compared to this one? It's the same. Almost the same. Now some interesting information. Okay, configuration. You can mix and match these different panic handlers using Better Panic for debug builds and Color Irie and Human Panic for release builds. Code below also prints the Color Irie stack trace to log error for good measure after stripping ANSI escape sequences. So you can combine Color Irie, Human Panic, Better Panic. Here's code you can copy and paste into your project if you use a TUI struct to handle terminal exits. Color array panic section. Human Panic is here. Human Panic format, author and support. Author and support. Okay, so I think this part here is maybe something you can display at this section. You can open a support request at, oh, it's not here. Okay, so it's just to show you can mix Better Panic with Human Panic. Better Panic. If it's just Better Panic alone, yeah, Panic Handler and you have Better Panic. Panic Handler, Better Panic is here, while Human Panic is here. So you can do both. This one is debug assertions, not debug assertions. But this is debug assertions. Better Panic for debug builds. So Better Panic for debug builds. Okay, so Better Panic debug assertions. Then Color Irie and Human Panic for release builds. So maybe that's why there's not here, not debug assertions. Okay, so we still have time. Let's continue with migrate from TUI-RS. Ratatui is a fork of TUI-RS created to continue maintenance of the project. Fully replace TUI-RS with Ratatui, which is the preferred approach. Use Ratatui as a drop-in replacement alias as TUI. Support both TUI and Ratatui. I think once you start creating Ratatouille apps, just like for hello Ratatouille, this one is already using Ratatouille, so it's not the UI. So don't see any reason why you should. If you're starting with a fresh project, so I think there's no need to migrate. Support both TUI and Ratatouille for more complex scenarios for a library, or in some cases in an app needs to support both Ratatouille and maintain existing support for TUI. May be feasible to use feature flags to select which library to use. Feature flags. CTUI logger for an example. Five months ago, 9 months ago, 7 months ago. Oh. Ratatouille. I think we can skip this. It's not needed for now, I would say. Maybe let's move on to this one. This is spawn external editor vim. In this recipe, we'll explore how to spawn an external editor vim from within the TUI app. This example demonstrates how to temporarily exit the TUI, run an external command, and then return back to our TUI app. What do we have here? Okay, so Ratatouille init, restore, and then terminal is inside here. So let's jump to run. You have the infinite loop, then draw, terminal draw, handle events is here. Either you press Q or E. Terminal draw. Okay. It looks incomplete. So it says here is the main function and then the event handling logic. Okay, so event handling logic is here. After initializing the terminal in main function, we enter a loop in run function where we draw handle events. Handle events listens for key events and returns an action based on the key pressed. So action, this action, edit file, quit, or none. Here we are calling run editor function on action edit file. Run editor. Where is run editor? It's not here yet. Okay, so spawning vim. Here's run editor. Let's define the function run editor function attached to action edit file. Action. Run editor. Execute leave alternate screen. Disable raw mode. And then command. Okay, so this one is the one that can run Vim. Opens up a text a.txt from temp folder. std out, execute, enter, alternate screen, enable raw mode. Terminal clear. To spawn VIM from our TUI app, we first need to relinquish control of the input and output, allowing Vim to have full control over the terminal. So that's why we have disabled raw mode here. The run editor function handles the logic for spawning the Vim. First, we leave the alternate screen and disable raw mode to restore terminal to its original state. This part is similar to what Ratatui restore function does in the main function. Ratatui restore. Let's close this one. Here, Ratatouille restore. Next, we spawn a child process with command. Okay. Which launches Vim to edit the given file. At this point, we have given up control of our TUI app to Vim. TUI app will now wait for the exit status of the child process. Okay, so it will wait. So as long as Vim is running, then it will be in this process. At this point, we have given up control of our TUI app to Vim. Our TUI app will now wait. Once the user exits Vim, our TUI app regains control over the terminal by re-entering the alternate screen and enabling raw mode. Lastly, we clear the terminal to ensure TUI is displayed correctly. Okay. So, a side note, before running another application from your app, you must relinquish control of the input-output. In the example above, we use a simple event handling setup. However, if you are using advanced setups like component template, you will need to pause input events before spawning an external process like Vim. Otherwise, Vim won't have full control over key bindings, and it won't work properly. Using the TUI module of the component template, you can do something like this to pause and resume event. Here, TUI exit. So status. Okay, to pause and resume event. Is it this part? TUI exit. Edit file. How is it different from this one? Disable raw mode. Then you have command. Command status. TUI exit and TUI enter. Terminal clear. TUI module. Okay, so this is TUI. This is not Ratatouille. That's the difference. This is TUI. One more thing to note is that when attempting to start an external process without using the pattern in the component template, issues can arise, such as ANSI RGB values being printed into the TUI upon returning from external process. This happens because Vim requests the terminal background color and then the terminal response over std. Those responses are read by crossterm instead. If you encounter such issues, please refer to okay, using select macro plus cancellation token plus Tokyo as in template avoids this problem. Running this program will display hello Ratatouille, press Q. Okay, so where's the program? Where is it? Code. Okay, maybe we can open up a new one. What should we call this? Cargo new spawn big game. So let's put this under main rs. Yes. Then include this as well. Editor. Still errors. This wrong. Which command? Which command? std process command or crossterm command? std terminal terminal. Ratatui terminal. Terminal is here. There's always missing with this example codes. Draw. Terminal draw. Render frame. You can do something like this. terminal is this. Terminal. Missing generics for struct terminal. Terminal clear. Okay, so that's Ratatouille terminal. Terminal. Let's remove this one. Default terminal. Yeah. Okay, so that fixes it. All right, so let's try. Small VAM. Of course, no. I have VI. Will it work? VIM, or should it be VI? Let's try first. Cargo run. Edit file is E. No such file or directory. Okay. So there's no VIM. It means I need to change this to VI, and maybe instead of something like this, I'll put just this run. So edit. There you go. This is a test. WQ, and it goes back to this one. Success. Okay. Alright, so that's how it works. Mainly this part here where you can spawn another process, so calling VI in this case. And then status will wait for it until the process exits, and then enable raw mode once again, clear the terminal. Okay. Right, so I think I exceeded a little bit. At least we managed to get something running here. So far we have covered these things. Releasing your app, what we have here, some guidelines. Some guidelines. Yeah, we can go through this on the next day. And then maybe let's explore on some showcase here and see which one we can adopt later on as well. We can do a mini project. And yeah, so that's how we can proceed in applying Ratatouille. I'll be doing a mini project. Right, so let me end here, and first let me thank my supporters. Thank you so much for joining me today.